So I just wanted to record a quick video to talk about the why the transformation rules that we talk about in class work the way they work. It seems like a very unintuitive thing for a lot of people because the A is just a vertical dilation by a factor of A. The K is just a vertical translation by a factor by K units. But these B value, the B and the H, have this weird behavior, or seem to have this weird behavior, where B is a horizontal dilation by a factor of 1 over B, and H is a horizontal translation by a factor of negative H units. And so these two seem like they have an inverse relationship. What's going on there? And the answer to that is there's a very good reason for this, and it's actually the A and the K that are the ones that are backwards. So let's go ahead and take a look. So let's just go ahead and start with the coordinate mappings that we talk about, way back in geometry. If we want to take a point xy and transform it, we're going to map it to another point. In this case, let's just make them exactly what we want. We're going to make it b times x plus h and a times y plus k. So in this case, b is the dilation factor in the x direction, h is the translation in the x direction, a is the vertical dilation factor, and k is the vertical translation. And just like order of operations, in this case, the dilation happens first, multiplication would happen first, then the transformation or translation happens. Just like with A, dilation first, then translation, because the multiplication happens before the addition. And that's another thing we look at in here. Even though, according to the order of operations, the H, the translation, would happen first, we know that the B happens first, which is, again, very strange, or seems very strange. So let's just go ahead and take a look at this. As most things, if we look at the actual algebra here, it's going to make a little more sense. So, in order to map x to b times x plus h, basically what we're saying here is that we're going to let x prime, the image of x, equal b times x plus h. And similarly, we're going to let y prime equal a times y plus k. These are just the image points based as an equation from the original points. Now, in order to make this equation to substitute these values into our equation, we've got to actually solve them for x and y, because we're dealing with the original equation, y equals f of x of some kind of function. So to solve this equation for x, we'd start off by subtracting h from both of these and subtracting k from both of these. So x prime minus h equals b times x, and y prime minus k equals a times y. Then we'll divide both sides by b, and divide both sides by a. So here on this side, we end up with x equals, I'm going to write this as a fraction, 1 over b times x prime minus h. And on this side, once that cancels out, y equals 1 over a times y prime minus k. Now you'll notice right away, this part here on the x is exactly what we typically think of as being inside the f on most of our transformation rules. It's the inverse of what we wanted to do to b, and it's the opposite of what we wanted to do to h. We also notice that exact same rule applies to y, so why isn't the y values that inverse just like the original x values? So let's go back to our equation. In general, we have an equation y equals f of x. All we're going to do this transformation is substitute these values in. So 1 over b times x prime minus h is going to go in substituted for x. 1 over a times y prime minus k is going to get substituted for the y value. And at this point, we'd have the equation 1 over a times y prime minus k equals f of 1 over b times x prime minus h. And so at this point, written this way, both of these variables have that inverse relationship. Even though 1 over a is the multiple out front, a is the dilation factor. Even though 1 over b is the multiple out front, b is the dilation factor. What changes here is we want to solve this equation for y prime. We want to write it as the image of the original function. And to do that, we'd first multiply both sides of our equation times a, and we'd end up with y prime minus k equals a times f of 1 over b times x prime minus h. And then simply our last step is going to be to add k to both sides. And when we do that, we end up with y prime equals a times f of 1 over b times x prime minus h plus k. And as you can see here, if we go back up to the very top, to get a dilation factor of b means that we have the inverse in our function. Now we typically write that the other way. We'll put b here and say the dilation factor is 1 over b, but they're inverses of each other. They're reciprocals of each other. That doesn't matter. Here we've written the negative h inside the parentheses in order to get a translation of h units. And in the normal way we write it, we put an h here, and we say our translation is negative h units. Just another way of saying it's the opposite direction. And so that's the explanation. That's kind of the why is the a and the b and the h and the k, why is that behavior different? Why does the stuff inside the function behave differently than the stuff outside the function? And the real answer to that is, well, it really doesn't. It all comes back to this step right here, where actually both values have that inverse relationship, and we've just solved it for y, and so we've had to put the a and the k back in where they go. So hopefully that helps make this make a little more sense, and you're not sitting here wondering, why are those the inverse?